Hello students, welcome to our channel Chem Reactions. So today we're gonna discuss Cannizzaro reaction. A very important point about this reaction is there is no need any alpha hydrogens for this reaction. So first of all, like we have formaldehyde. This is formaldehyde. Can this formaldehyde reacts with a concentrated base like NaOH, KOH, sodium hydroxide, potassium hydroxide? So we have given like concentrated NaOH for suppose, and a heat is also given for this reaction. Okay, so let's see how this reaction proceeds. This reaction, after this reaction, we can make here, after the reaction, we can make here an alcohol as well as a salt. So salt of an acid is formed like a sodium formate is formed in this reaction, and this alcohol may be formed in this reaction. So first of all, what should we require? So we have written here that there is no alpha hydrogens for this reaction. So alpha hydrogen should not be given for this kind of reaction. Like if you have asked that benzaldehyde gives Cannizzaro reaction, so answer should come yes, it gives Cannizzaro reaction. And why it is? Because it doesn't have any alpha hydrogen. So this is the only reason here. Now let's start with the mechanism first. What the mechanism suggests. So let's see the mechanism of this reaction. First of all, it has given that this aldehyde, this formaldehyde, when reacts with this base, that is OH minus, how they react together, this OH negative becomes as a nucleophilic part and it attacks on this aldehyde as a nucleophile. And whenever this base attacks on this carbonyl group, it occurs nucleophilic addition reaction, and after the nucleophilic addition reaction, this OH minus attacks here on this carbon atom, the CO bond shifts, so it should be like this. Negative charge on oxygen atom, there is H, and OH attacks on this sp2 carbon. And then after a same molecule, we can proceed the reaction further. So another mole for this. So this is the very first step of this reaction where this anion or this base attacks, and in the very next step you can see a same mole of aldehyde, a same mole of formaldehyde is used, and so thereafter, hydride transfer takes place in this reaction and it becomes as a rate determining step, so which is considered as the slowest step of this reaction. And how this hydride transfer takes place, the CO bond once again shifts on the according to the electron negativity difference, where oxygen is having a more electron negativity. So just see now what is now gonna be happen. Just this is the very important step where hydride transfer takes place. This negative charge once again convert into the bond, which is nothing but a double bond. So it looks like HC double bond O and then OH, which is nothing but a carboxylic acid, and the other species which looks like HC negative on oxygen atom, H and then H. We have done a nucleophilic addition here. Then after hydride transfer becomes as an RDS step, this formic acid attacks on this alcohol. I am writing once again for this step like it is CH3O negative, and this hydrogen atom once again attacks on this oxygen and forms as salt of an acid, and the other product looks like CH3OH, where this H plus attacks on this more En oxygen atom. So this is the mechanism, and through this mechanism we can find the alcohol as well as salt of an acid. So this is the Cannizzaro reaction we can perform here. Just look at that example. You have given a benzaldehyde. So this is the benzaldehyde. How? The question is, concentrated KOH is used by the use of high temperature. So benzaldehyde, how will it react? So first of all, you can see, to identify this reaction, there is not any alpha hydrogen. So if no alpha hydrogen in this reaction, it can convert into alcohol as well as an acid. Just check it out. It forms as a salt of an acid, and another product it can obtain like an alcohol. So this is the alcohol here. Okay, so this is about the Cannizzaro reaction and its mechanism as well. So please subscribe this channel, Chem Reactions, like, comment and share this video with everyone. Thank you very much.